Hello there. Welcome back to well, uh, line. What line are we on? I changed a few things. Uh, Now this whole thing about structured exception handling is kind of it involves a little bit of research on my side, and so I got a little bit diverted from where we were, and I also did a little cleanup here. I don't need this recast of the array is fine for the printing of the context. So I changed that. No extra variables, no memcopy. This here, I should just take that away. This has to do with something that's going to come up. Two of these. What this here is, this is from C, I'm calling a C++ function that is exported as C, and I wanted to see if there was any object unwinding that occurred after the long jump, and the answer was no, which I expected. However, the code tells a slightly different story, and I believe we were on this line on the last video, and I don't know what this video is going to be called yet. So I don't know what we're what the where we're going to end up. But anyway, let me just run up to this point where we were sitting. We saw how this thing got filled in. That was quite simple. Now, I made a correction in the last video. There's an annotation. This should have been a C, right? Because there were two pushes and a call, so that's 12 bytes. So what we stored in what would have been the SP part of that struct, this member, would have been ESP at the point of call plus an extra 12 bytes, right? Sorry, the current ESP, because it's growing down, we've subtracted 12, so the current ESP is the ESP at the point of call plus 12. Might be easier to see it the other way around, but you'll see in a minute. Now the rest is the same. So this is what we knew at the end of the last video. And now I've summarized it here. So what we have is base pointer at point of call, and base register. I looked in that, this document that we were using over and over again with testing the Notepad program. It has some terminology in here, and I went searching through it, and I found out that where is my thing? Where is it going? Here. Oh yeah. But even these registers have names, believe it or not. The B here in EBX stands for base, and this is called the base register. So there's base pointer and base register. So I got these names out of there. A is for accumulator, C for counter, and D for data. This is the data register. There's no name for FS, okay, or GS, as far as I can tell. I've searched, and I did a little looking up, trying to recall what I could about the layout of at this FS. Now, FS is certainly special in the sense that all these other, they're not segments. Okay, these numbers are not even called segment numbers. So they're called what are they called? Selectors. Okay, these are called selectors. Whenever you try to put 0 in for any of these, where any of these selectors would apply, right? Be it stack or data or code, you would get an access violation. But that's not true for this FS. FS0 doesn't crash. You can read and write to FS0. So that doesn't. This one actually is, even though it's still within the same memory arena, it's offset from 0. However, at position 18, this here, fs:18, gives you what they call the linear address. That's what all these other addresses are based on. The linear address in our memory space of what's called the TIB, okay, thread information block. This is all thread specific. The FS data, the stuff that goes in here is different for different threads. So each thread gets its own exception chain and whatnot. But anyway, we're not anywhere near that. Okay, so source index, destination index, everything else is the same. Nothing else new. So this is what we know. Base pointer, this is what we've stored off. Base pointer, the original stack frame base pointer, the base register for some reason. Oh, I know what the reason is actually. Destination index and source index. We also have stored the stack pointer at the point of call -12. And we put that in this variable in our struct. And EIP is pointing at the return address, not at the point of call, but at the return address. Now, FS0 is something that they've just called registration. There's a reason for that. It's these, like I said, there's a kind of linked list with the structured exception handling, and there's a chain. There's a linked list of handlers, and the 0th one is at this position. Okay, this is what they call the 0th frame, and there are more and more frames. Try level is at 1. Now, I thought this might be the debugger, but actually that is not true. I've just found out it is 1, but it's not because of the debugger. It's not because the debugger has a try in front of our in front of the program. Turns out that there's always something called a default unhandled exception handler. Okay, and I think that one corresponds to that default, and that one's placed in by the operating system, I think. This is a mystery. I really don't know what this stands for, why this number and what it means. And we had 0, and this was never filled in by us, and I think it's meaningless. I think we could fill it in if we want with, garbage instead of. We're getting zeros because we're declaring our things, global scope here, and I'm setting that equal to 0. I could set it equal to something else. Why don't I? When we first come in here, let's see, mem set them all set equal to I want to know it's me that said it. A1 for Al. Actually, A0. I want A1 for the other one. Just for, it looks better. Now, I believe that those values will not be disturbed. And by the time I get to this line, there they are. See? Except this one it was set deliberately to 0. And these are not 0, they're what I set them to. Okay. But now it's too long and it's wrapped around, so how about I wish there was a D word set. Or, well, we can't do that. Let's see. Now, I don't know if this, no, that won't work. I think there are 16 of these. Make our D words 1. Just a byte word. I'm pretty good define for it. I'll use the define. JVLAN. Okay, doing that. I'm going to set iRed again. We could call this T or something for temp. Alright, this shouldn't look as bad. There we go. Alrighty. So now one thing I didn't have in the printout before was the registration thing, which was FS0. Okay. And in the lingo of structured exceptions, that's the first exception frame or something in the linked list of frames. SEHF, first structured exception handling frame. And that's meaningless, and it should be, because we haven't got there yet. Try level, this I think comes from the operating system. Cookie, meaningless, unknown. BX, I don't know why it has this value, it's just randomly was equal to that. Okay, now we're going to go into foo, and it's going to call a bunch of things, and we're going to end up here. By direct call. Now, why am I here? That's not where I am in the code. Okay, get rid of that then. So now we're moving into AX, the exception number, which is I don't know what it is. I do. It's 13724. (359C) 724. Oh yeah, that's right. Okay, so that gets pushed on the stack. And then mark here is our mark 0, right? Shows all those funny numbers. It's a big array. And we're pushing just the pointer to that on the stack, and we're now calling long jump, which I started trying to write the algorithm out in like C style code, and then it turned out that it's just easier it reads easier in assembler than in C. However, there is a buffer declared here, or sorry, allocated here, 50 hex. Okay, and it's one of the values is being set to this dword value, 8,000 blah 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 26, whatever that means, I don't know. And so it's an array, it looks like an array of D words. So I just said, okay, there's a D word buffer, and it turns out 50 hex is the same as 20 decimal D words, or 80, that makes 80 bytes, right? 80 in hex is 50. And that's the amount allocated here. Now at EBP minus 50, which is the first element in this buffer, which I just called buff, goes this value 80026. Don't know why. And the next 4 are set equal to 0. This is the next to last, and going down by 4. So 5 of these values get set. So now there are 15 random ones, or unset ones. Don't ask me why, but I think the reason comes up later. Now into yeah, this confused me for a while. I was looking at this as EBP, but it's not. It's ESP, which we just subtracted 50 from. So this really says previous ESP plus 8. And so that's the plus 4 would be the last thing pushed. So this is the first thing pushed. Can't be, because the first thing pushed is this number, I accept. And that's not it. Anything now. Plus, oh yeah, there's the return address. So this is plus 8. ESP, if this were in terms of EBP, I don't know why they don't use EBP. This is EBP plus 8, right? EBP plus 8, if you didn't have this subtract here. And EBP plus 4 is pointing at the return address, and EBP plus 8 is pointing at the last thing pushed. And the last thing pushed, according to the reverse order pushing, is mark. Now, in the help file, well, there's something else I found out too. Let me just get this over with first. We're doing a long jump. They call this env for environment, so I use the same terminology. Okay, so into bx goes env, and then into bp is the first thing in env, which is from our struct. EBP that we saved off, and that is the actual base pointer for the stack frame at the point where the set jump was called. Okay, so we'll restore EBP. What I wanted to mention before I forget was I know now that I read this column. And the reason I know it is because I found in here something that I only vaguely remembered from years ago, and I could never find it again, which was what the rules were to do with names beginning with underscore. You know, I was thinking about this Schmidt guy, and he must have been a real pain. And this is his inaugural column or whatever, right? After getting this great job at Microsoft. And he keeps knocking Microsoft, and he's always like, where is it? The first example. Here he's talking about like the standard names, right? What does the C standard say? The C standard says that you don't use standard.io.h, you use standard.io with no h, right? And then this line becomes this line. That's what it's supposed to be. Subclause D5 from the C standard. Okay, so you know the guy's a real pain. And now, but he's able to answer this question. From subclause 17.4.3.1.2, global names tells us that the compiler implementer reserves names beginning with double underscores, has reserved any names that begin with a double underscore or a single underscore followed by a capital letter. Each name that begins with an underscore is released. Double underscore or underscore followed by uppercase letter is reserved to the implementation, which is the compiler implementation. And like I used to write this sort of thing down a lot, and I thought maybe that either I'm supposed to do that or I'm absolutely not supposed to do it. And I'd read somewhere where it had explained one way or another if this is okay or not. And here it is. So this is not okay. If you're writing this down in your programs, underscore, blah, 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 like this, that's a reserved symbol, and you're not allowed to do that. So I just went through my code and went to see where I was doing that, and there were a few cases, and I got rid of them. It's perfectly fine to put a little letter and a single underscore, apparently. Now I know that a lot of people do that with their classes and class members. They will start with a little underscore and a small letter, and that's fine. But if it were a capital letter, then that would be bad. Now the wizard, and anyway, I don't know. Interestingly and unfortunately, the Visual C++ app wizard can generate source code usurping reserved identifiers. For instance, if you create a new service with the ATL.com app wizard, the resulting skeleton code defines names like underscore handler with a capital H. And what's wrong with this one? That's reserved too? Oh, okay. No, nothing. You can't use an underscore anywhere in the global namespace, right? Yeah, okay. In the global namespace, no underscores at all. So it's probably okay for a member variable. This is bad. I'm pretty sure that that app wizard thing used to puts weirdo. Anyway, it's irrelevant, right? The guy's just nitpicking, I think. But mostly I was kind of curious because I see in our old code, unfortunately the compiler is very forgiving, and it doesn't give you a warning or an error or anything when you do something like ASM, right? Now that, and it even comes up green. Well, what's the difference between that? And which one should I use? And I've always wanted to know the answer. Well, the answer is you use the double underscore one. That's the correct one for any of these things. So double underscore try. All right, back to where we were. We are stepping through the code. We fill in the first 5 bytes of this buffer for some reason unknown to me. Now we're putting the address of that buffer into AX. Okay, now why we would do that, I don't know. Here's my code. I've left that part out. It's not even... Okay, well, we restored the base pointer. from bx. Oh, that was here. So we restored the base pointer. Now, oh, okay. So this base point, that's not our base pointer. That's the base pointer of the bx. I see. Okay. We restored only bx, nothing else yet. Okay. And now into BP, we're putting bx. Okay, now this bit with AX is unclear at the moment, but BP minus 50 should point to this. And well, it says BP minus 50 is that Virdo code, and but that's not what ended up in AX though. Oh, effective address, I see. So star of this should give you that. And okay, but why? Maybe that's our return code or something. Now we are about to put into EBP what's pointed at by BX, and BX is the base pointer of the target environment that we're going to jump to, right? Of the stack frame we are going to re-enter. So here we're restoring the base pointer. So now that the current stack frame is the original stack frame where the set jump was made, right? We restored EVP, but BX is pointing at the data n, the variable n. This is why this is easier in assembler to see, because none of these values are any good anymore, right? The stack frame is not pointing at the stack frame of this function currently, but bx, the register value, is pointing at the thing that was passed into this function, this jump box. Now 18 was the registration value, right? And we're putting that into SI. Okay. SI. And that is what it was, I remember. Right. There it is, registration. Same as SI here. Now that was the first thing. That was FS:0, right? All right. Now we're comparing SI with, no, this has got to succeed, right? They can't. Well, no, it may have changed. I see. If at some point between when the set jump was made and now, if the structured exception handling chain was altered, then this would not return the same value that we saved off. Okay, so we're checking to see if that's true. If it has changed, if they're equal, then we're going to something called, and they will be equal in this case, local unwind. Now this is what got me confused. Unwind what? I mean, how are we going to unwind anything as a C program? Well, anyway, the label is here, and that either jumps to no unwind or something called old unwind, and old unwind calls a specific function called unwind to local unwind 2, which I don't know what that is. But I could imagine some things like open file handles or something, right? Maybe if it goes into this old unwind, that might do an F close all or something, I don't know. But it doesn't go in here. Of course, we haven't set anything up. Maybe your proper practice is to set up either set up an unwind handler, right, to go into here, an unwind, you can spell that right, unwind, not W funk, that does some cleaning up, or do something else. Anyway, this hasn't changed, and apparently, and I didn't fill this part in my pseudocode. I just left this blank because I figured there's no way we're ever going to get in here. But that's not true. I won't look at that. Okay, so here we are at local unwind. Now, is SI, remember SI was pretty much star FS, basically, right? FS colon 0. If that's 0, I don't know how it would ever be 0, but it's possible, I suppose. Then go to no unwind. I see, maybe it's 0 if that default handler wasn't put in there. That I'm sure it's not to do with the debugger. Well, we can find out actually. But we would do no unwinding, no attempt to unwind if that's 0. No, it wasn't 0. We're putting into AX BX plus 20. Remember, from like an hour ago. BX still contains that N, and plus 20 is the cookie. So we're putting into AX cookie and pushing it and calling a thing called probe read. Now, I didn't write it all down here, but this is the way I've written it in pseudocode. So check if SI is 0, no unwind, call probe read 4, that means probe 4 bytes at address cookie to see if we can read there. No, that's 4B something something. Plus 20 AX. Now. Is our cookie still there? AX. That should just read cookie. It is 5643 blah blah blah. Okay. Now we push that onto the stack, and we're checking to see if we can read it. I don't understand why it's being so careful about bx plus 20, whereas prior to this, it's reading bx plus 18 with no worries, but bx plus 20, it's calling this probe. Don't ask me. Different person came in, made a modification. Oops. Check AX40. I would assume that would mean a false. We're not able to read cookie from end. If equal, go to old unwind. If AX come back 0, now I don't know. This could be one of those functions that returns 0 on success. Oh no, can't be, because it returned a 1, and you can see that I'm able to read 4 bytes worth of from this address, so that would be fail. So on the fail case, it goes to old unwind, which we haven't looked at. Didn't fail, succeeded. Now we put that into AX. The cookie, and comparing it with this hard-coded number, which is what it should be, which is what we set it to, it is equal to that. If it's not equal to that, again, old unwind. So if that changed, go to old unwind. So there are two things that were tested for any modification. The SEH FS0 value and cookie. If either of those change, what happened when this no unwind. If no attempt at all to unwind it where this changed. Old unwind if this changed or is different or not equal to what it should be. If it's not equal, but they are equal. So now this, I assume, is this standard code. So this here is the assembler. Is the no errors condition or something. Everything will A-OK. So everything's A-OK. We load up the unwind function, check to see if it's null. If it is null, then we don't do any unwinding because we don't have anything to unwind with. Otherwise, we push the environment onto the stack and call the unwind function. So that now we know what that prototype is, right? And you will note that there's no cleanup. So unwind function is a standard call, probably, although it's not 100% certain. And then jump to no unwind, which is our way of getting back home. So okay, so therefore the clean unwind is a standard call, it cleans itself up. Because if we could either have fallen to here, or we could have gone through this mechanism, and this stack pointer ought to be the same in both cases. So therefore this thing is a standard call, which takes one pointer argument which is a context block from set jump. So it turns out in our case there is no unwind func. That's what this here 24 was. Unwind func. And there is none. So we're at no unwind. So this is the code where we have no mechanism to do an unwind, no mechanism to clean up after a long jump. Alright, now it calls this, okay, this is just a retake at this spot. Now I'm going to run from here over this thing, this function, which I think stands for non-local go-to, notify, something like that. Notifies something, I guess, about what we're about to do for some reason. But most importantly, you'll note that okay, well, this I just did a push, so this changed from an 8 to a 4. I put something in EAX, call the function, and let's go back to 8. So the only thing that changed from here to here was EAX, and it's not used anywhere. EAX is reset again at this point, so it has no effect on the rest of this function. So we can ignore it pretty much. Okay, I'll clip this part in with the rest. So it's a push. So this turns out that calling this thing restored the stack. And I don't know what else it did. We can step into it later. 5C would certainly give us the first thing that was pushed, which is the 14226 in this case. And now we're comparing it with 1. Why 1? There must be a special meaning to 1. But there's nothing in the code to compare with 1. I mean, there's nothing explicit. What are the flags? There is no carry. Add ADC, the instruction add carry, adds to AX whatever this value is, and one more if the carry flag is set, which it isn't. But this is, I don't know what this is all about. Now, ESP we're restoring from N, from the environment thing, and calling. Oops. I've got it written down clearly. It's ESP at point of call. Sorry. Which one are we restoring? DX plus 10 stack pointer. Okay, yeah. So it's point of ESP when the call was made minus 12, right? And then we're adding 4. So now that's ESP value is ESP of point of call minus 8. Okay. So you see the point here. If this is now ESP minus 8, right? That's just as if somebody called set jump and pushed 2 arguments on the stack, then that means that they would have to clean up the stack pointer by adding 8 to it. So we jump to the set jump call where 8 is being added to the stack pointer to clean up, and that gives us our stack pointer back, and we're exactly where we were, except that EAX is not 0 anymore, it's this. Okay, the rest worked. Well, I guess you have, well, depending where I'm cutting this off, you will have seen anyway, I hope, how all this works, and that for some reason there's a comparison. The number 1 has a special meaning, not sure, and there's really nothing further about long jump. Okay, so now I don't want to say much more about long jump in particular, but in keeping with the goal of speaking about things like random crashes and whatnot, there's another type of use of this long jump, set jump and long jump, that can deal with asynchronous events, things like crashes. One example I have here is when an exception occurs in the floating point unit, which is unpredictable, or it's not something that you throw deliberately. You don't raise any exception. It gets raised elsewhere and interrupts your code. And so I'd like to just go over that example next time, and then we'll move on to C++ exceptions, and then finally structured exceptions. Okay, so till next time, see you.